Look up at the night sky, and you are not looking at now. You are looking at ruins. Every point of light you see left its source before this moment existed for you. And by the time it reaches your eye, the star that made it might already be gone, dead, scattered into dust, and you would have no way of knowing. You are at this very second staring directly into the past, and you cannot look anywhere else. There is no version of looking up that shows you the present. This is not poetry, this is physics. And once you understand what a light year actually is, you will never look at the sky the same way again. A light year sounds like a unit of distance, and technically it is, but that phrase hides something much stranger underneath it. It is the distance light travels in 1 year, moving at roughly 186,000 miles every single second, the fastest anything can move in this universe. That number alone should stop you. Light could circle the Earth 7.5 times in the space of one heartbeat. And yet, even at that almost incomprehensible speed, it still takes light over 4 years just to cross the gap to the nearest star beyond our Sun, Proxima Centauri. 4 years at the fastest speed permitted by the laws of physics just to go next door. The universe is not just big. It is built on a scale that seems almost designed to humble us. But the real terror isn't the distance. It's the delay. Because that delay means the sky is not a window. It's an archive. The sunlight warming your skin left the sun 8 minutes ago. If the sun vanished right now, this instant, you would still see it shining for 8 more minutes. Still feel its warmth. Still watch it hang in the sky as if nothing had happened, living in a lie built entirely out of old light. Now stretch that outward. The light from the star Betelgeuse left over 500 years ago. Astronomers already suspect it may be nearing the end of its life, possibly ready to explode as a supernova. It could already be gone. It could have detonated decades ago, and we would have absolutely no way to know until the light of that explosion finally completes its 5-century journey to Earth. Somewhere out there, that light might already be on its way to us right now, carrying news of a death that happened while medieval kingdoms were still being carved on our own planet. This is where the physicist Leonard Susskind, one of the founding architects of string theory and a man who has spent his career forcing human minds to accept truths our intuition rejects, would ask you to slow down and really sit with what this means. Susskind has spent decades studying black holes, information, and the true structure of reality. And one of the ideas he returns to again and again is this: our instincts about time and space were built for a world of tables and chairs, for throwing spears at animals a few dozen feet away. Evolution never prepared our brains for a universe where seeing and now are two completely different things. When you look at a galaxy 100 million light years away, you are not looking at that galaxy. You're looking at a photograph, one that took 100 million years to develop, of a place that no longer exists in the form you're seeing it. The galaxy has moved. It has changed. It has aged 100 million years while its old light finally arrives at your retina. And here is where it gets genuinely disorienting. If light years measure the past, then looking far enough away means looking far enough back that you approach the very beginning of everything. Astronomers have detected light that has been traveling for over 13 billion years. Light that left its source when the universe itself was still in its infancy. A hot, dense, chaotic newborn cosmos. That ancient light is still arriving. It's still crossing space, hitting telescopes on Earth right now, carrying a direct visual record of what the universe looked like before our sun, our planet, or a single human being had ever existed. We are not guessing what the early universe looked like. In a very real sense, we are watching it happen, just impossibly delayed. This naturally raises a question that keeps physicists up at night. If we can see light from 13 billion years ago, does that mean the universe is only that old? Not exactly. And this is where the light year reveals another layer of strangeness. Because the universe has been expanding this entire time, the space between us and that ancient light source has stretched dramatically since the light first departed. The place that emitted that light 13 billion years ago is now, due to cosmic expansion, roughly 46 billion light years away from us in terms of actual present distance. The observable universe is a sphere with a radius of about 46 billion light years. even though the universe itself is only about 8 billion years old. Distance and time have become tangled together in a way that breaks our everyday assumption that you simply divide distance by speed to get time. Space itself has been stretching underneath the light the entire journey, like an ant walking across a balloon that is simultaneously being inflated. This is the point where most people's understanding of light years quietly falls apart, because it forces a much bigger and stranger question. If distant light shows us the past, is there a place right now where a distant observer is looking at Earth and seeing dinosaurs? The answer, astonishingly, is yes, in principle. If there were an alien civilization on a planet 65 million light years away with a powerful enough telescope pointed directly at Earth, the light reaching them right now would show a Tyrannosaurus Rex walking through a fern forest, because that's the light that left our planet 65 million years ago and is only now completing its journey to them. Somewhere out there, in some hypothetical vantage point in space, the asteroid that ended the age of dinosaurs hasn't hit yet. It's still en route. This isn't science fiction. It's a direct, unavoidable consequence of the finite speed of light combined with cosmic distance. Every moment of Earth's history is still traveling outward into the universe, a permanent, expanding shell of old light broadcasting our entire past to anyone positioned at the right distance to receive it. Which brings us to something even more unsettling, the idea that there is no single universal now. Susskind, drawing on Einstein's relativity, has explained that simultaneity itself is not absolute. Two events that appear to happen at the same time to one observer can appear to happen at completely different times to another observer moving at a different speed or standing at a different location. When you factor in that light itself takes time to cross space, the very concept of right now across the universe starts to dissolve. There is no cosmic clock ticking the same moment everywhere. What you call now on Earth is a purely local experience, valid only in your immediate neighborhood of space. Stretch that out to galactic scales, and now becomes almost meaningless. The universe doesn't share a single present moment. It's an ocean of countless local presents, each one only connected to the others through light that takes years, centuries, or millennia to cross the gap. Now push this even further into territory that made Susskind's career. What happens to light and to time itself near a black hole? This is where the light year stops being just a measurement of distance and starts revealing something about the deep architecture of the cosmos. Near the event horizon of a black hole, gravity becomes so extreme that it doesn't just bend light's path. It stretches and slows the very passage of time relative to an outside observer. If you watched a spacecraft fall toward a black hole from a safe distance, you would never actually see it cross the event horizon. Instead, you would see it fall slower and slower, its light growing dimmer and more redshifted, seemingly frozen at the edge for what would appear to you like an eternity. Meanwhile, from the perspective of an astronaut aboard that ship, they would cross the horizon in an ordinary, unremarkable instant, feeling nothing special at all, before being torn apart by the immense gravity deeper inside. Two completely different, equally true experiences of the same event, depending entirely on where you're standing. Susskind spent years locked in intellectual combat with Stephen Hawking over what actually happens to information that falls into a black hole, a dispute now remembered as the Black Hole War. The heart of that argument was this: does information, the fundamental data that makes up everything, including you, ever truly get destroyed? Susskind eventually helped prove, through ideas tied to something called the holographic principle, that information is never lost. It gets scrambled, encoded, spread out in ways that seem chaotic, but it persists, preserved somewhere in the very fabric of space-time itself. Stay with that idea for a moment, because it connects directly back to light years in the past. If information is never truly destroyed, and if the light carrying information about every event in the universe's history continues traveling outward forever, then in some very real sense, the universe is a library that never stops writing itself into existence, one photon at a time, spreading outward at exactly 186,000 miles per second. forever encoding what has already happened for anyone, anywhere, positioned to eventually receive it. This raises an eerie possibility that theoretical physicists have seriously considered. If you had a telescope powerful enough, and if you positioned yourself at exactly the right distance from Earth, you could theoretically watch any moment in human history replay before your eyes, not as a recording, but as the literal physical light from that event finally arriving, the signing of the Declaration of Independence, the construction of the pyramids, the birth of your own grandparents.
All of it is still out there, expanding outward from Earth in a sphere of light that has been growing for as long as those events have existed.
4 light years thick for something 4 years ago, 65 million light years thick for the age of dinosaurs, forever preserved, forever traveling, forever theoretically retrievable by something somewhere with the right position and the right instruments. And this is where the truly vertigo-inducing implication arrives. If our past is permanently encoded in expanding light, then somewhere in the incomprehensibly vast universe, assuming any civilization exists with technology far beyond our own, they could be watching us right now, except not us as we are today. They'd be watching some frozen slice of our history, delayed by however many light years separate us, an old rerun broadcasting on repeat, with absolutely no way for them to know what we're actually like in this present moment, and no way for us to know if anyone is watching at all. Susskind has often emphasized that the universe doesn't owe us an intuitive design. It operates according to consistent mathematical laws. Whether or not those laws feel comfortable to primates evolved for savannas and social groups of maybe 150 individuals. Light years in this light aren't just a unit for measuring cosmic real estate. They are a constant, humbling reminder that we never see reality directly. We see its echoes. Every photograph you've ever taken of the night sky is, in the most literal sense possible, a photograph of history, layered thousands of times over, star by star, galaxy by galaxy. Each point of light a different chapter, a different century, a different epoch, all arriving simultaneously in your eye as if they belong to the same moment, when in truth they are fragments of radically different pasts, compressed into a single deceptive glittering sky. So here's the question worth sitting with long after this video ends. If everything we observe is already gone by the time we see it, if the present moment is fundamentally unobservable at any real distance, if the now you're experiencing is stitched together entirely from other people's pasts arriving late, then what does it actually mean to say something exists right now at all? Is the universe you're looking at tonight the real one, or only the last surviving echo of one that has already moved on without you? And somewhere out there, light carrying the story of this exact moment, this sentence, this thought you're having right now, is already beginning its journey outward, destined to arrive somewhere, sometime, long after you're gone, as someone else's past.